So tell us how a gizmo works.
So this is one of our growing plants gizmos, and basically what you want to do is you want to take a look at the gizmo, and you can start by a couple different ways. We want to set up the gizmo, and we want to keep all the variables the same. So let's change and manipulate our water. Let's do everything at 70 milliliters. So I'm manipulating all three, A, B, and C, and let's grow a bean plant. And let's do an experiment on height to see who can grow the tallest plant. Let's do one light.
Same amount of water, different number of lights, okay?
Absolutely.
Okay.
So what we're going to do is we're going to run our experiment for 50 days, and we're going to collect data. So right now the gizmo is collecting data on height and mass, and you can see they're getting taller and growing. And I can click over to my data tab here and see what's happening. Or I can click back to my experiment really quickly. I want to pause this really quickly, and let's take some observations here. Let's take a look. On plant A, we've got 35.8 centimeters, plant B, 37 centimeters, and plant C, 30.6 centimeters. So right now, our tallest plant is the
37
yeah, the plant B in the middle. So let's see. It's only got one light. Let's make a prediction. Which one do we think is going to grow the tallest based on what we see here?
Wow, just right now I'd say that plant B is going to be the one that grows tallest, but I know that plants love light, so but look at that one that's got all those leaves, so maybe that'll make a difference. Gosh,
True. So
I don't
let's
know.
start looking at some of those things, Tim.
Okay.
Let's keep playing. We're going to play for 50 days.
You go, Kristen. You go.
Let's keep going. So plant C is really full, and it's got lots of mass, lots of leaves. Plant B, it's slowing down a little bit. Plant A is getting really tall, though. So our experiment's complete. We can look at a couple.
50 days.
Yes, sir. We can look at a couple different things here. We can look at our height and mass, and we can look at our data. Why do you think plant A actually grew the tallest?
Because it was trying to get to the light.
You're exactly right. Have you ever seen a tree in a forest that's growing away from the shade? It's actually growing from that shade in direction of the light. So most of your students think that all a plant needs to grow and be healthy is light.
Okay.
That's not necessarily true. So gizmos can do a couple different things. It can clear up some common misconceptions, and you can do that with our gizmos and our lesson materials. We have lesson materials available in Word and PDF. So if you're going to walk through these, this is our student exploration guide. And you can scroll down to our Gizmo warm-up activity, and then you've got activities A, activities B, and activities C.
What's the difference between A, B, and C?
Well, it's great for differentiation. So A is going to be your easiest, B is going to be a little bit more difficult, and then C is going to be your hardest activity. Usually by the time you get to activity C, you're designing your own experiment. Let's go back to our lesson info, and I want to show you a couple of different things. We also have an answer key. We have our teacher guide. This is great because this gets the teacher up to speed really quickly.
What teak is being addressed?
Actually, you can go to our correlations, and we are actually aligned to the teaks in all areas of gizmos.
Okay,
so,
now I'm going to ask you this because this is like the mystery question that nobody seems to be able to answer. Are they also aligned to the technology application teaks, or are they just aligned to the science teaks?
Let's take a look at that. I'm going to take you to our Texas standards here, and I'm going to scroll down to our teaks. What we've got for science is a couple different things. If I go to our 5th grade, you're going to have your teaks with your student expectation. You're going to have your ancillary materials here. You're also going to have your Proclamation 2014 correlations up at the top and your English language proficiency standards. So we do meet all the 21st century technology requirements based on the TEA requirements. However, there's no specific alignment that we have on our website.
Okay, so you can't say that it's meeting this technology application team?
Not at this time, I would say.
Okay. That's okay. That's all right because nobody else does either, so don't feel bad.
So if I scroll down, I'm going to see the student expectation, and where I see a gear, I'm going to see a gizmo that's correlated to that actual standard. So we have, like I said in the very beginning, about 475 plus gizmos in our library. When you get a login to Gizmos, you get access to all the gizmos in our library, math and science, because we consider the gizmos to be cross-curricular. We want you to have both content areas.
So are all of the science teaks covered at each grade level?
This adoption, you didn't have to meet 100%. I would say in 5th grade, IPC and physics, we are 100%. The other ones are going to be covering the teaks, but they're not going to be meeting them all 3 times.
Okay. Well, here, let me help you up because you're on your knees. Okay, hang on. So tell us a little bit more. Why would somebody pick Gizmos over another adoption, for instance?
I would say Gizmos are research-based off the book by Dr. Robert Marzano, Classroom Instruction That Works. And in that book, he does a meta-analysis where he looks at students who use manipulations or simulations versus students who don't. And he shows a 43 percentile gain in his study where students who use simulation have better student achievement. So I would go so far as to say students that have Gizmos in their classroom have great preparation. It's going to make abstract concepts more concrete, and it's going to give the teacher availability to inaccessible objects and to do a lab in a short amount of time. As a teacher, we don't always have everything we need, so Gizmos are a very quick way to get your students further, faster, farther. Thank you.
So I can also see the Gizmos being used as kind of an introduction to a lesson. Say we go back to that one about the plants growing. You do it on the computer, but then you also do it in real life as well to see if the real life matches the computer, and then you have a discussion why they may match or why they didn't match.
Absolutely. We try to make a connection with every Gizmo so it's a real life experience. We want you to leave with a mathematical connection, an environmental connection, a sports connection, a technology connection, something that you can take into the real world and apply it.
Kristen, thanks for talking to us. Appreciate it.
Thanks, Tim. It's good to see you. Glad to be here.